I think we're ready to beginify with the programming. Now, we left off things last stream with a couple of to-dos really big, but let me recap where we've gotten so far. So what we're doing here is we're doing a tutorial for people who are pretty new to game development or Unity or something like that. And we're making effectively a Pac-Man clone called PuckMan. It's the story of a Zamboni driver who's trying to collect all the pucks in the arena before the goalies catch him. Similar to, but legally distinct to, Pac-Man. So that's going to be the idea. And we've gotten to the point where we can, in fact, navigate the map. We've played a little with tile maps. We've got a very simple character controller for our dude over here, and we can move around. Now, the thing we were working on last time is it would be nice when we switched our direction backwards that it switched instantly. Right now, the way it works, and it works properly for these intersections, is it sort of kind of cues it up for when it enters the tile. Because it makes sense. Like, if I hit it now, we can't start moving up yet, but it'll start moving up at its earliest convenience, which is kind of what we want. But if we hit backwards here, it finishes its move into the next tile before turning around, and it feels a little bit weird and laggy. And we're experimenting with a couple of different things to kind of fix that. So that's one thing we're going to take care of. The other thing, you might notice every now and again a little green line that shows up, and it's especially viewable over here, visible over here. If I just sort of scale this up, and there you go. At every certain sort of zoom levels, occasionally you get these little green lines. Or, well, the green lines is because of our particular sprite map, but sometimes you'll see little gaps, or you'll see something else. Sometimes you'll see these little artifacting between tiles, and what is the cause of it, and how do we fix it? And it turns out, I mean, I knew last week, but turns out the explanation can be I can really explain it quite simply, and the fix is also extraordinarily simple. There's a couple of really good simple fixes that we can employ, so we'll talk about that in just a second. Ms. PuckMan was a better game, fight me. I mean, Ms. Pac-Man was a huge step forward in above the original Pac-Man. A much more interesting and sophisticated game. I mean, still, you know, kind of primitive from today's standards, but no, it's a very solid game. I think there's a lot more proper like variation and RNG in Ms. Pac-Man, because the original Pac-Man could basically be solvable with like standard sort of like you just move in a certain pattern and you could clear every map without ever touching a ghost. It was pretty sick. That like people figured it out, but it's because there's no real RNG. There wasn't anything like significant like that you could really work on at first. All these things we take for granted, there were hard problems to solve at some point. Okay, so the first thing we're going to fix is... actually, we'll fix the code first. Then we're going to fix this graphic glitch. Because the code fix should be pretty simple. I mean, really... Oh, the other thing I fixed, we were having issues with last time, where my code completion wasn't working here. Like, if I were to go... target pause dot... I wasn't getting this. And it turned out all I had to do, and it was probably because I updated my thing at some point. If you do run into this problem using Visual Studio Code like I am, if you just go to your edit menu and go preferences, and in the external tools thing, just regenerate your project files and restart Visual Studio Code. Solve the problem in 2 seconds, and that was that. And now my autocomplete is working. So there's just something broken in the project file. And again, it may have been because there was a version change in Unity at some point before we started the tutorial, or I don't know what it was. Okay, so that was that problem fixed. So what we want to do over in Maze Mover, way down here, we have this function called set desired direction. So when the player hits an arrow key, right? This is in the player mover code over here. It, like, you know, reads the arrow keys, it figures out what the player wants to do, and sanitizes it in different ways. And all it does is tell the maze mover, hey, this is the direction I want to move in. I want to move in this direction, please and thank you. So Maze Mover is responsible for this, and it's going to also tie into the AI. Like, the AI is going to feed set desired direction to this, but the Maze Mover is responsible for actually, you know, legitimizing it. Like, if you're trying to move in the direction that's not legal, then it's just going to ignore that input and that sort of thing. And so what we want to do is we want to make the player change direction immediately if we're just turning backwards rather than waiting for the next tile to come in, because it's going to feel a lot better. And really all we have to do is call update target position over here. But we only want to do it when we're reversing our direction. Now, I think the way we have this put in, literally all we have to do is check if we're flipping the X or flipping the Y direction, and then calling this. I think everything else is in a state where it's being sanitized and treated properly, that the only thing we have to do is just call update target position when the right thing happens. We're going to try it. I'm going to go and do this. There's not going to be an if statement here, and I'm just going to check to see if this correctly makes our left and right feel proper. Very snappy. What I want to do is check if I hit right and left immediately. Okay, doesn't let me cheat through the wall. What about this way? Left and right? Nope, doesn't let me cheat through the wall. Excellent. The only thing is with this, if I move left and then hit up over here, rather than wait until we hit this intersection to move up, it'll start moving up right away and sort of doing a weird diagonal. Like that. And then it keeps going because it's very confused about things. So what we need to do is just make sure to call this if we're going the opposite direction. Now, what we could do is an if statement where if the new direction .x is less than 0 and the old direction .x is greater than 0, or the opposite where the new one is greater than and the other one is less than, or whatever it is, we could do that. I think, though, and I don't think it makes much of a difference, but I think if we do something like if, because if you multiply two positives together, you get a positive. If you multiply two negatives together, you get a negative. If you multiply a positive and negative, you get a number, a negative number, right? Here's her old direction. If we do, if old deer dot x times new deer dot x is less than 0, that means we're flipping our direction, right? I think that's correct. Now, is this, the most efficient and effective way? I think this is a pretty nice way to do it. So we do this, or if the same thing but with y's. Again, I'm counting on you guys to double check my math, just like when we're playing Factorio. If there's a better way to do this, use dot product. I see what you're saying. Yes, a negative times a negative comes up positive, but that's still the same check. If they're both positive or both negative, our movement is in the same direction, so we don't have to do anything. But, sorry, I might have misspoke. But basically, the only way that a multiplication comes out less than 0 is if one is positive and one is negative, right? So, if we do this, we should only be instantly updating our target position if we're specifically flipping. I don't think we need to check if they're not changed, because if they're both the same, then it's still going to be 0 or above, right? If, let's say we're moving straight up and down, well, old x and new x, they're both going to be 0. Multiplied together, they're going to come out to 0, so they won't be less than 0, right? Again, I'm fully prepared to be wrong about this. It ate the input because it's still compiling. That looks right. No weird diagonal movement here. What you're doing is basically a dot product, but checking the dimensions separately, since I think it built in. So, okay. Now, it's been a while since I've done my, that kind of math. So, you're suggesting vector2 dot old deer, new deer. And is it the same thing if we do this and if it's less than 0? Does that mathematically work out similarly? Apparently so. See, it's a good thing we have math people. This is beautiful. Thank you, math people. Here, I'll leave the old note in. Need to brush up on vector math. Totally forgot what dot and cross. I know that a cross product gives you another vector, and a dot product doesn't. And you can use a dot product to check to see if things are, like, perpendicular or parallel to each other? And is it also used maybe to help calculate the angle between two vectors? It's been a long time. Math is important, kids. It's funny, you actually don't need a ton of very advanced and complicated math when you're doing programming. The exception might be some stuff in shaders where you're going to use a lot more angle stuff. And occasionally you might use a little calculus for something, but it's pretty unusual. I know there's some slightly headier math in some of the neural net kind of stuff, but even then, there's not that much. But this is one thing. Knowing how to like work with vectors, that's definitely having that would save you a lot of trouble. And you know how to work with angles. Basically, be comfortable with sin, cos, tan, and vectors. And then you're actually going to be set for probably 99% of the math you're going to run into in game programming. If you want to have the angle, your vector should be normalized. Okay. I'm a software engineer for 20 years. I can't math. And what's funny is like, and if you're not doing game programming, you're really not going to do a lot of math in your coding. Most of my professional programming career was doing business application development. And I mean, other than just, you know, adding up dollar values or something, wow, there wasn't a lot of math stuff to do. Okay, so we have fixed that. Now we've got nice responsive input. Lovely. Let's deal with the visual sort of glitch over here. So let's talk about why this is happening, okay? So we have our tile over here. This is what that tile looks like. It's the four-way connector. By the way, if you missed it, we do have the, where's the right window? In this sprite sheet we've got here, we've got like all the variants of the various connectors. We can make a very pretty looking map. We just haven't bothered with it because we're still changing the map. So there's no reason to draw it all pretty yet because we might make some modifications. Probably I won't even bother in this tutorial. But anyway, we've got this. So we're just using the middle one right now for simplicity. Now you can see in this actual physical sheet, so we have a single sprite sheet, which has certain advantages. A single sprite sheet, and we're going to come back to this in a second when we talk about atlases. A single sprite sheet has an interesting advantage for optimization on the computer in that you just feed basically, well, you don't do it manually, but the way it's going to work in Unity is it just basically feeds this entire sheet to the video card as one graphic. The most intense operation you can ask your video card to do is any operation whatsoever. It has to do with like the number of sort of commands you run. The video card's actually really good at doing lots and lots and lots and lots and lots of stuff from one command. It's each draw call that you send to the video card. Each one of the draw calls is a huge amount of overhead. And you can limit how many draw calls and how many interactions and how many transfers from hard drive to RAM to video card memory you have to do by having basically all of your graphics in a single sprite sheet. It just puts it into the graphic card once and then can keep working on that. It's really great. Now for our game, performance isn't going to be an issue, so it's a moot point. But it can also be very convenient to work with. You just have this one sprite sheet. People can, you can sometimes mod things. You just replace the sprite sheet as a whole. It's very convenient. So this is one graphic in here. But you can see in this particular graphic, they have put a little border between each tile with some green pixels, which is fine. They could have just left this blank, so you'd have a blank gap between them, or they could have not had any padding between each one of these cells and have everything squished together. Those are all valid things, and none of them prevent the problem that we're seeing here. In fact, the advantage of these green lines, I tend to use like a super bright annoying magenta, right? Like really obviously wrong. The advantage of having this is it makes it really obvious when something is not quite right. These little green lines over here, these are not right. And if we just had a plain background, you'd see a little gap instead. Might be a little less obvious that something is happening, but you would still see a little gap between these guys. And so why is that happening? Well, all right, so we have our, where's my Photoshops? Over here, we have our graphic here, and this is 20 pixels wide. It's 20 by 20. Now, if we happen to be drawing this on the screen at a zoom level and or distance or whatever in such a way that it's going to be exactly 20 pixels wide, it'll look perfect. It'll also look perfect if it happens to be 40 or 60 pixels wide, right? Some multiple of 20. The problem is, what if because of various zoom levels that we're operating in or whatever the heck is going on, what if this graphic is only going to take up 19 pixels or 21 pixels or 30 pixels or 105 pixels, because it's being, exploded on your monitor. How is it supposed to... How am I supposed to deal with that? Let's get back to this in just a second. Doing ski things. I was gonna parse that as doing ski things. I'm like, that doesn't sound right. Doing ski things. Holy crap, man. Thank you. Man or woman. For too long I've been freeloading your content. No longer. Now subscribed. And here's something extra. Enjoy a bottle of Lagavulin 16 on me. Yeah, that is my absolute favorite whiskey. I actually just went to the liquor store yesterday. I don't know if I'm going to be able to make a withdrawal from the Whiskey and Chocolate Fund that soon again. Oh man, but I have something super awesome to look forward to. Holy crap, thank you so much. That's insane. Thank you. Alright, let's get back to programming. Focus. B1 with the code. Alright, I'm back. So yes, if we have an oddball number of pixels, right? So this 20 pixel graphic might not take up 20 pixels on the screen. Like right now, it's taking up way more than 20 pixels. So then it gets into this thing as it's trying to figure things out. Like, let's say we're trying to show it at 21 pixels wide, then obviously one of these pixels is going to be kind of doubled. Now, depending on your filtering mode, it might do sort of a smooth sort of blend from one pixel to another, or if we're running with no filtering mode, which is what we've got it set here, it's going to be a hard copy of one of the pixels. So if this ended up being 21 pixels wide, basically it would sort of choose one of these columns and just double it up. Or if it's 19 pixels wide, it would sort of take one of these columns and kind of have to drop it. Now, in all that, you know, adding columns, removing columns, with floating point math and all kinds of things, sometimes what can happen is as it's doing that, it apparently can sometimes grab the next pixel over here with the default way this sprite editor and sprite slicing works, which to me honestly doesn't seem like the sort of thing it should do. The math should probably be adjusted that it never overshoots this block. Better to undershoot it than overshoot it. Now, again, and if it wasn't for the green line, we'd still be grabbing some sort of pixel here, whether it was a blank pixel or the pixel on the next image over. Now, there are two super simple solutions to this that doesn't require you to have to do weird camera math, which is what I was thinking last week. One is with a Sprite Atlas, which we'll talk about in a scooch. But the other, and potentially more simple way, is to eliminate the single sprite sheet and use individual images. And here's why. When you have an individual image like this, and this texture, this image gets loaded into the video, it has to know what happens if the program asks to draw a pixel that's outside of the bounds, right? What's happening with our big sprite sheet, sometimes it's clearly asking to grab a pixel that's outside of the bounds, and then it's grabbing that green. But here, what would happen if we tried to read this pixel right over? Okay, fine, thank you, yes, okay. This pixel right over here. What's the correct behavior? By default, if you're bringing in a regular texture for 3D modeling, it gets set to repeat mode, where just, you know, because it's sort of tiles or whatever, right? You got a brick texture you're putting on a wall, you just want it to repeat. So if you're going out of bounds, what it's really doing is it's looping to the left-hand side, and then keeps reading like that, and then loops around and keeps doing like that. Which, honestly, for this texture, would actually be okay, because if you, for some reason, you're reading a tile out of bound here, it wouldn't necessarily be the worst thing to grab it over there, because it's mostly symmetrical, although with shading and things like that, it might not be. The other thing you can do, and this is the default when you're working with 2D sprites in Unity, is instead of repeat mode, it sets the clamp. Get the clamps. And what clamp does is if you go out of bounds, it just keeps repeating the last pixel over here. So if you keep going to the right, it just keeps copying this one over and over and over and just stretches and smears that out. Or, you know, it copies the left one and smears it out that way, top, bottom, that sort of thing. That's with the clamp mode. And that ends up being probably the most correct solution for our tiling problem, is because really all we're saying is, yeah, I mean, if you need an extra pixel, we just want you to duplicate one of the pixels that are here, so duplicate the right edge. And so by having an individual tile like this instead of being in a sprite sheet, then it's going to use the clamp behavior, and you're not going to get a green pixel or an empty pixel or whatever. It's just going to duplicate something in here, and it's going to look right in those zoom levels. So if we go, easy fix. So if we go into our tiles here, so our tile map doesn't use sprites directly. You have to create a tile, which is this one, and it points to a sprite. Right now, it's pointing to the sprite that is sliced from our big sprite sheet. What I've also done is I've got the solo sprite over here. If all I do is go into this tile and link it to the solo sprite instead, instantly fixes the problem. Now, you'll still see a green line sometimes. Where was it? Oh, You can just see it blink in next to our hero character over here. Oh, almost got it. Ah. No, I can't stop it on right one of those. Because it's like probably 120 pixels that's got it, so figuring out exactly where to stop the mouse and not overshooting it is hard. But you can see it there because our character is still using its version from the sprite sheet. And so it's still going to have that at some zoom levels, but we could fix it by making the character... Oh, there we go. Just did it by accident, stop there. We could fix that by making the character into his own solo as well. There is one other solution, though. Let me go and return this to the old sprite here. There we go. So this is part of the sprite sheet. So all the visuals that you're seeing are part of the shared sprite sheet. But what we can do is we can use a Sprite Atlas. Is it from here, or do I have to... There we go, Sprite Atlas there. It's probably in another category here. I wonder which one of these has it, because it must be in here. Well, I say must. It might not be, actually. Huh. Oops. So the other solution is to use a Sprite Atlas, which apparently we can get to from over here. Boop. So, we'll just call it New Sprite Atlas. That's fine. We'll probably want something smarter later on. And then we have to add some sprites to this that are going to be packed into a single sprite. So if we take our walls... oh, which one of these is the one? What I'm going to do is I'm going to delete the old one. The standalone one right over here. Because I'm going to get confused otherwise. Still has multiple ones because... Oh, that's the tile. Do we point at the sprite or the tile? I don't know if it matters. Okay, so what should happen here... with the Sprite Atlas. Now, we might not actually see it in the preview. It might only come up when we build it, because that's what people said, is you have to build it. What the Sprite Atlas does is it makes a sprite sheet. Basically, the same thing we've got here, it's making a sprite sheet. Now, what's nice about this is you can use this when you've got a bunch of individual graphics like we had, right? If we don't have a single sprite sheet, but we have a bunch of individual graphics, it might be a little easier to work with. But what we might want to do for that optimization, where we only have a single graphic that we're uploading to the graphic card and saving draw calls and really just being a lot more optimal, what we might want is still use a sprite sheet. So what this does is basically builds a sprite sheet for us, the Sprite Atlas. So it's got there. And it's got this packing value. What it's doing, since obviously the texture like repeat behavior, like repeat versus clamp behavior that we were just talking about, because that can't really apply here. Instead, what it does when it generates the Sprite Atlas, it adds padding over here. So you can see it's automatically stretched this out. You don't see it with this character because it's just got blank tiles that it's doing it. But it's adding this padding, and we can change the padding side. You can see there it's tweaking a little bit. It's weird that it's not showing the way that I thought it would. You can see here, see how this is getting shorter and longer? I don't know why it's so long over here. Probably has to do with like power of 2 math or something. But you can see right here, it's changing how much it's padded by. Now, I don't think it matters how much padding we've got. Probably 2 pixels is enough, but we can make it 4 for safety. And then if we use this, it should be okay. I think if we went and built the project, it would automatically use the Sprite Atlas. Whenever we're using one of these sprites, I think it would look it up in the Sprite Atlas and use it kind of auto-magically for us. What I'm going to do is I'm just going to resave this thing, and we'll probably just use this. Wall northeast southwest. I'm going to keep closing. Oh, it's not actually maximized. Oh, because I'm trying to click on the toolbar to bring Unity in focus. And the best thing to do is you just slam your mouse at the top. Because the thing is, and here's the thing, there's certain, all operating systems, they would always have this little border. So for some of these buttons, right? They would have this little border there. And it means if you could miss it, you could overshoot high. But what's nice here is the toolbar, because it's scooched up against the top of the monitor, it's basically an infinitely tall button, right? An infinitely tall button. So if I just slam my mouse up to the top and then click, I'm going to click on the toolbar to give it focus. But I didn't realize it wasn't maximized, so there's a couple of pixels. So every time I wanted to focus this window, I would do this and it would click the thing behind. One of the great things I love about the Mac, don't get me wrong, obviously I use Windows a lot. On the Mac, the menu bar is the topmost thing. They don't the title bar isn't the topmost thing. The menu bar is the topmost thing, which is beautiful because effectively each one of these little buttons here on the Mac is infinitely tall. So it's really easy to hit the menu because you can just slam your mouse this way. All you have to do is worry about left and right motion. Tiny little optimization that you should keep in mind when you do any programming for like an application or game design is think of the edges as an infinitely wide or tall button. Super handy. Anyway, so I'm gonna not worry about the main dude, but I will replace the wall here again. Oops, I gotta set this back to 20 and apply. There we go. And I want sharp, crisp pixel graphics. So yeah, we're gonna turn off the filter mode on that again. Excellent. And we're not gonna worry about the green line next to this guy because we know how to fix it. We know a couple of different ways to fix it. Excellent. Hokindoke. Now we can start on some new things. So there's two things I want to work on today, if at all possible. One, I want to get some pellets in the game here so that our little PuckMan, waka 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 waka, can go and pick up some power pellets. And the other thing I would like to do is potentially get some ghosts with some AI in here. Let's work on the pellets first. Not because they're easier. In fact, they probably won't be. Because we're probably going to do some fancy tile map stuff. So ultimately, here's what we're doing. We're going to create a new object. And this is going to be a pellet that we're going to pick up. And inside of that, we're going to have a graphic. We probably have a pellety graphic in here. We could do like a coin. I don't know. I think this little white pellet, I think that's the way to go, right? I like this. So we're just going to go drag a rectangle. It's again 20 by 20, which is good. And this is just going to be called pellet. And we can apply this. So now we have a new sprite. Now again, the way we're doing it here, we might end up with some green line artifacts around it. But hey, we know how to solve it. We'll worry about that later on. So we get the pellet here. Now again, what I'm not going to do is I'm not going to have the graphic be the root object. Always make your graphics and usually your hitboxes and things a child of an otherwise empty game object, which has your game logic. All your code is going to be on this. The graphics are going to be here. It makes it much easier to swap in and out. Because again, if you decide to switch from a 2D graphic to maybe you're going to use a 3D graphic, there's no reason, even though it's a 2D game, we could have the power pellet be a 3D object that sort of spins and rotates and has shiny lights and does whatever the heck we want. We got that. We are going to want to make sure that the graphics are centered up within the parent, because otherwise that will be very weird and confusing to try to figure things out. And then we've got a pellet over here. We're going to do this. There we go. Looking nice. So we got a power pellet over there. Now, we're going to add some code to this. In fact, maybe we'll start writing the code for it now. No reason we're not going to. What I'm going to do is I'm going to put the pellet here. I'll just get it nice and centered up. And we want to be able to eat this pellet when we collide with it. Was Pac-Man 2 half circles with opposing rotations for animation? No, it was just drawn sprites. 100% just a drawn sprite, because doing rotation math and shit like that would have destroyed the old like Atari type stuff. We've had that on Mac for a decade. Or are you talking about like the toolbar being at the top kind of thing? Could be. Probably use the sprite and then tile needs to refer to the one from the Atlas. That might be it. It might that might be yeah, if the Atlas was going to be referring to the tile, or if this could use the one from the Atlas. We can poke around with it later, but we have effectively the solution, so we're going to move on to the newer stuff over here. Right, so this pellet. Basically, when PuckMan, the Zamboni driver, drives onto the pellet, we should pick it up. So, in a sense, that means when we collide with the pellet. Now, collision in the sort of like the physics system that is used by, well, most things at this point, but including the one in Unity over here, which is the physics system, PhysX system, and various things like that. A collision is a very specific thing. A collision is something that happens with two physics-enabled objects that physically bump against each other and then ideally sort of bounce off each other and things like that. That's a collision. Instead, we want to think of it more as a trigger. When the PuckMan overlaps, encounters whatever the pellet, that should execute a trigger that responds to some sort of behavior. That's why when your game object code, you have on collision enter, you also have on trigger enter. And on trigger enter makes way more sense when you're not actually using like the actual physics system. These are not objects that are interacting each other physically, because they're not bouncing off each other as a real sort of elastic collision. Instead, they're overlapping. You just entered into a trigger zone kind of thing. Now, both can be resolved with the physics system. What you'd want to do is you obviously need some sort of collision box, some sort of collider, some sort of hit box for the object. And that's one of the reasons I like to have it divided up here. It kind of makes sense logically to have our collider be sort of attached to the visuals, because the collider is probably going to be sized based on your visual. So that sort of fits in well together. Keep in mind, there's 3D colliders and 2D colliders out there. So in this case, we'd want to use 2D. And there's no reason we'd probably just use a circle collider here. I mean, you can use the edge collider, which will try to do the edge of the graphic and things. But a circle collider, A, is going to be just as clear, if not more so. And if you're worried about optimization, a circle or a box collider is much, much faster to figure out than these various edge colliders. So we'd probably use a circle collider over here. And how come it's not actually showing me the collider size? How come I can't? How come I'm not seeing a little green outline of our collider here? Well, there it is. Normally when you select an object with the collider, it shows it to you in green. Oh, is my gizmos off? I didn't realize my gizmos were off. Thank you. Okay. Yeah, sometimes I turn that off because there's too much crap, like with the camera icon and things, which you can sub-filter, do different things. Yeah, I didn't realize. So by default, this should be on. There we go. There's your preview right there. So what you could do is you could have this collider in here and do this. And this would work beautifully. You do need a rigid body. So on the thing, this would be enough for the pellet, but our player would need a rigid body. Now, the rigid body itself can be on the root. And in fact, it's much better than that, because if you end up with multiple colliders, and some objects are nice and complicated, and sometimes you'll just use a series of box colliders to sort of sketch out what the collision should look like, because it's very fast. And that's fine. They could all be children of something with a rigid body. But the fact of the matter is the physics system is probably super lots of overkill here in what we're doing. Well, there's pros and cons. So I don't know if one approach is actually going to be better than the other. This approach here isn't really what they probably would have used way back in the day, but would work fine. Because what we can do is we can just have it when you enter into a tile, check to see if there's a pellet there, and then, do appropriate behavior. Or what you can do is you can have each pellet just kind of keep track of the distance between themselves and the player. And if the distance is, say, less than 1, then it can be eaten. That's pretty straightforward as well. And I think that's what I'm going to do, because it's just a completely code-centric kind of solution. And might, in fact, be the cleanest sort of way to do it. I don't know. There's pros and cons to both. What I'm going to do, because we haven't really been doing anything with the physics system, I'm going to go and not use the physics system. I'm not going to use the colliders. There's nothing wrong with it, but I'm just not going to do it. The pellet definitely needs some sort of code. We can probably just call it pellet. We can probably just do this. I don't think there's a real problem with it. And we're going to give it some logic. No matter what, it needs something. If we're going to do like collision stuff, then we're going to need something like on trigger enter 2D. And there's a thing in there. We could totally do that. But instead, what I think I'm going to do is I'm just going to have this keep track of the player. And if it gets close enough, then we eat it. Just for the sake of showing a different way of doing things. So what we're going to want to do is we're going to want to keep track of the player. Keep in mind, maybe you end up doing a multiplayer game and you're going to have multiple player movers. Right, which is fine. There's no reason we couldn't do an array like this of players to keep track of all of them. Or maybe there's going to be an AI PuckMan that you're competing with. Consider that possibility, right? So it's not just a player mover that can eat pellets. Instead, what we might want to do is give the player another script that says something like we can just have it's a pellet eater. So the player is a pellet eater. Maybe other things are pellet eaters. I don't know. Battle Royale PuckMan. That, honestly, Kakaz, that could be a really fun game. Got a big maze, it's shrinking down, or, you know, being limited in what area, so you have to scramble to get over there. You're trying to eat things. There's probably got to be some way to, like, attack another player, maybe, or something. I don't know, or you pick up the power pellets and you go around eating other players. I don't know. So then we get this idea that we've got the idea that a pellet eater can be completely disconnected from a player. So all we're doing is something like, okay, we want an array of all the pellet eaters in the game. Now, if we're going to do something like this, so this has other issues because now all of a sudden every single pellet is checking every single pellet eater constantly. Maybe it's not correct. In fact, almost certainly it's not optimal, but I still wanted to have an interesting discussion about, well, okay. So here's the issue. If we do it this way, and we read it in some way, we do something like pellet eaters equals game object dot find objects of type all. Find objects of type pellet eater. All right, let's talk about the issue with this approach. I think I'm convincing myself that this is not the way I want to go. So this will grab all the pellet eaters, and then in the update we do something like for each pellet eater PE in pellet eaters, and we do this. Now, if there's 100 pellets on screen, they're all running this every single update, feels a little slow, doesn't it? Yeah, it probably does. And it's the same if we do the other way. If our pellet eaters look for all the pellets, and then every frame they check to see if they're close enough to one, that's also pretty slow. It also has the question of what happens when a pellet or a pellet eater gets eaten. So now all of a sudden we have to update this array constantly. Although this, we might have a global array of all the pellet eaters, which might be better. Then you could do some sort of like binary partitioning of the game space, and then you're only checking pellets within your sector and neighboring. Wow. I think we'll go back to using the physics system, because really this physics system is doing exactly what we're doing here. How does it check to see if one object is inside another to fire a trigger? Well, it's constantly checking every frame, every object that's moving around to see if they're close enough to overlap. However, internally, presumably, it's doing space partitioning so that the world gets broken up into smaller chunks, and it's only checking the objects within a chunk, which is much more optimized. And then Kakaz has an interesting point. Don't you have a move into area already? Here's the thing. Our pellets don't exist willy-nilly in our map. Right? If we come over here, our pellets, you know, aren't just floating in random locations and aren't like, oh, there's a bunch of them over here and things like this. Logically, when we're talking about a Pac-Man game, or sorry, PuckMan, the pellets exist one per tile. So wouldn't it make sense to simply check, hey, the tile I'm entering, does it have a pellet in it or not? So it depends what kind of game. If this is a loose, free-flowing thing, you know, a space sim where stuff's just kind of wandering around and whatever, then yeah, you have to use a more advanced approach where you're cycling through everything or using the physics system or something like that. But we're on a very strict grid with very simple assumptions. Each tile will either have a pellet or won't have a pellet, and that's it. If that's really the game rule that we're playing with, and I think in this case, so sometimes making assumptions like that is bad, but here it's like, no, that's a core part of the game design. Each tile either has a pellet or doesn't have a pellet. So now the question is, okay, can the pellet be part of the tile map system? Because it'll also be way simpler to draw it out, right? Right now, if I want to fill this map with pellets, I gotta, okay, duplicate you, I gotta move you over here. Oh, I have to make sure that you're properly aligned. Oh, that sounds terrible. Wouldn't we much prefer it if, just like how we can draw walls, right? If I go and bring up my, what am I looking for? My tile palette. You know, if I can just draw walls like this, oh god, that's convenient, and then remove it. Wouldn't it be nice if I could do, oh yeah, the alignment is a little wonky because of our grid offset. Wouldn't it be nice if I could do the same thing with pellets? Yeah, I think it would be. So what if we make a second tile map? I mean, duplicate the existing tile map, just because our settings will be there. And we'll call it the Pellet Tile Map. And then, in our tile palette over here, what if we just took our pellet sprite and dropped it in here? Right, like this. And now, so make sure we're on the right tile map, right? I want to be drawing on the pellets. What I actually might want to do is have two separate palettes so that I don't confuse the two. But I'm now on the pellet tile map. And now what I can do is I can draw waka 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 waka, kind of like this. Now, it's important to note that what am I drawing here? I'm just drawing tiles. They're not game objects. They're not from prefabs. Now, there is actually a very convenient, handy-dandy pre-made package that I will... Do I not have it open? Oh, I don't have it open. Unity 2D Extras. So if you Google Unity 2D Extras, I'm going to post a link in Twitch here, but if you're watching this on the YubTubs afterwards, if you Google Unity 2D Extras, you're going to get a page that is by actual Unity people, more or less. It's on GitHub. And it's got a bunch of extra little helpers, including some ready-made new brushes for the tile map system. Do I keep closing this? I should just move it to the other screen so I don't have to open it that way. Because right now, we only have the one default brush. But there is one that's an example of using a prefab as your brush. And this can paint any kind of prefab can be placed on the grid. We use this in our Dr. Deckenstein Escape from Castle Brainia game. We use that because our coins are actually 3D objects, I think, that spin. No, I guess they're still 2D sprites animated, but they're prefabs. And so what you can do is you can all of a sudden drop prefabs. So if we did have our pellet here made into a prefab, we could then do that, and then it would have all the code. But right now we don't have that, right? We have, let me get rid of you. All these are just tiles that are drawn. There's no game logic on this. In this case, though, this is totally fine because we don't really need any logic on the pellets, do we? There's a little bit that we might need, because what we can do, the same way that in our maze mover code, we check to see if a tile is empty before we move into it, right? We're checking the wall tile map. Well, when we move into a tile, we can check the pellet map to see if it's empty or not. If it's not empty, then it means we need to eat a pellet. The one downside is that how do we differentiate between a regular pellet and a power pellet and a fruit? I mean, a regular pellet, you need to clear all those to end the game, to end the map. The fruit just gives you extra points. The power pellet obviously enables turbo mode. How to differentiate between those? Because as is, there's not a lot that goes on here. When we get a tile over here, right, this get tile position, what this returns is an object called tile base. And this doesn't really have a lot. It's got this get tile data. Wait, that doesn't do what we want. I mean, it returns get the tile data as a reference, but ooh, you know, like, is it really going to be very helpful? There's limited kind of information. One thing you can do is you can subclass from tile base and use that as your custom tile. So let's say we did something like that. Let me make, I mean, this might be confusing, but it's the same thing in programming. There's a multitude of approaches that you can take for just about everything, and which one is right kind of just depends on, I mean, your particular case. One might be slightly more optimal or faster or easier to work with, but ultimately there's going to be a lot of different ways to get there in the end. So let's say we made, so it's called tile base, so let's call it tile pellet, just to keep going with the naming convention. So we've got some sort of script over here, which is going to inherit from tile base as opposed to mono behavior. which I think needs using tile maps, like that. So we've got some sort of object that's derived from it that exists in here. Now, do I have to do anything special? Yeah, I have to design a new brush, right? With the... Yeah. To use the other type of object. I think I make a new brush, and it can use that new tile. And then what you can do is over here, when you get your, in your maze mover here, when you get your tile, you can check if it's a, if it's actually an instance of pellet tile versus whatever. So that's one option. And it's very strong. The easiest and simplest may in fact be exactly what E11M is saying. Or actually a few people are saying. You could, what if you just use different maps? Right? Like we're gonna have this sort of the same sort of way that we're grabbing a reference to the wall tile map, right? And then we might get something like the pellet map. We could have another tile map for, say, the power pellets. And a fruit map and things, and then we just check each one of these individually, and then we do logic on that side. Now, this doesn't appeal to me strongly for a few different ways. One, it would technically allow us to put a pellet and a power pellet and a fruit all on the same tile. I mean, when we're designing the level, we would try to avoid that, but technically it would be possible, and that's weird. It also means that our, say, our pellet eater over here, when it's checking, it's got to keep checking all three of those maps. And what if we decide to add one later on? Well, then we got to go and loop through all those things. And it feels very awkward, doesn't it? Doesn't it feel really weird? So in the end, I don't know what is effectively the perfect combination of not being so confusing for a tutorial, and whatever. If we did bring in the 2D extras, and we brought in the prefab, then we could use the, because it would be the same as us just manually placing a game object in here, and then we could have our hitbox and our collider and that kind of detection, and it would be very convenient. And it's probably, the more I think about it, the more I think that might be the cleanest. It's all 6 of one, half a dozen, you know? Well, you can have an array of integers that will correspond to a tile location, and that's true. That would probably be how it would load in, and you would check, and then it would just update that from one to the other. But there'd be a physical disconnect between the pellets we're showing. Now, if in the old ways of like actually doing it, we wouldn't use a tile map. We'd actually have that bitmap representing what each one of these is, and then every frame we would just draw the correct graphic based on that. But we're using Unity to draw graphics. We're using a tile map system to place the graphics. So we could keep updating it from the grid, I suppose. We could just have a script, say, on the pellet tile map that basically just has a code on it that says, is there a pellet in this tile? Eat this pellet in this tile. Are all spaces filled until entered by a puck eater? No, because first of all, there's no pellets in the goalie net, and again, the power pellet location wouldn't have a pellet on it. It would have a power pellet, but they work differently in code. You know what might be the sexiest? Rather than having, so I'm you know, looking for a third solution, right? Because I'm like, well, either it's the mover that checks on the pellet state, or we have individual pellets checking things. What if instead we did just have the logic on the tile map? That actually is probably the sexiest, and we could use literally the same code for both. Ooh, all of a sudden I like that the best. Okay, we don't have the pellet code. We don't need that. We're gonna need the pellet eater tag. That's gonna be okay. And we're gonna make a code instead that's called it's sort of it's pellet tile map sort of, but it can actually do multiple things. It's basically just a pickup tile map, but we'll call it pellet. Now we probably will use this or maybe subclass it for the fruit and power pellet variant, but the root behavior is going to be exactly the same. So instead, what we're going to do is we're going to have the one map script, because what's nice about this is with the previous way of either having each pellet eater check every pellet or every pellet check each pellet eater, your code was going to be like, oh, like X times Y complexity, because each thing was looping over each thing, so it multiplies. But here what we can do, now we still need a reference to all the pellet eaters in this particular solution. An array with all the pellet eaters. Now, it would probably be a good idea to do add code for pellet eaters to signal updating this whenever they die / respawn, if that's something that happens. Right? Imagine we do make a multiplayer game of this. A player logs in, well, that's a new pellet eater. Player logs out, we got to remove the pellet eater. So we'd probably have a little bit of code to register and unregister pellet eaters to this. Beyond the scope of what we're doing here, but consider it if, depending on what you're doing. Instead of fruit, why not have poutine? Eurastus, amazing. 10 out of 10, perfect game design. Thank you very much. For us, we're going to do a one-time grab over here. So we use GameObject.findObjects of type, which will return an array. And we're just going to look, give me all the pellet eaters of the game start. In our particular iteration, we don't have creating or uncreating of pellet eaters, so we don't have to worry about the rest of it yet. Maybe that'll change depending on how we go. And so on every frame, what we kind of want to do is just say, is a pellet eater on a tile with a pellet? What does a poutine sprite look like? Oh, and then there's the waffles. That would be another good one too. So for each pellet eater PE in this, we're gonna have some sort of function. Check pellet. So we're gonna loop through each one of these. Like that. And what's nice is we don't have to loop through every single pellet, because actually there's no way for us to loop through each pellet here, because pellets are not game objects. In our current version that we're working on here, a pellet is not a game object. It's simply a tile on our tile map. That's all it is. There are hotkeys. There we go. D for delete. Yeah, the alignment makes it look a little weird for the drawing because of how we've got our offset. But it's working well. So we've got that. So they don't exist as a game object. So there's nothing, we can't really loop through it, which is fine, because all we want to do is say, what tile is the pellet eater in? And does it have a pellet? So in our maze mover, we've got some code to do that. Maybe duplicating code, whenever you're doing it, you've got to think, oh, maybe there's another way of doing it. Maybe there's a better way of doing it. But we can probably, more or less, just copy this. Is going to be okay. In fact, I'll probably copy those two. But maybe this does make sense for us to expand to something else. Tile base doesn't exist because we don't have the tile map namespace in here. Tile maps, that's good. Boom. And really what we want is tile map, my tile map, or this tile map, because we want to get our own, right? Get component has gotten smarter in Unity, where it does actually cache things, but it's still not a bad idea to go and grab this. So we're grabbing our own tile map. What's nice about this, we don't have to go looking. We don't have to make sure, oh, we've got the correct link. So what we have in our maze mover, which by the way, will have to be updated right here because now there's more than one tile map. Right, in the maze mover, it needs a reference to the wall map, and we had to give it that link in some way. And right now, because there's only one tile map in the scene, this is an easy way of doing it. But now there's more than one tile map in the scene, this might grab the wrong one. So we're gonna have to find a more robust way of properly getting a copy of the wall tile map. What I might do is literally just throw a component called wall tile map on the correct one, and then we can go and find the object that way, which is basically how the Unity component system, or the entity component system, sort of finds and filters certain things. We may do something like that. But this right now, to do, we broke this. We'll come back to that in a sec. But what's nice here, it just gets this tile map off itself, because this script belongs to itself. Easy peasy, lemon squeezy. So then what we want to do is over here, we're just going to check. So this is our code from before, which just gets a tile at a certain position. So this is a world position, and it turns this world position into a cell for our tile map, and it just returns that. And we can check to see if it's empty or not, which is really the only logic we're trying to do. So for our pellet eater, we can say something like, you know what? I don't think we need the is tile empty, because we're going to be doing some other checks directly with that. Yeah, I can just call it tile. So, first question is, what tile is the pellet eater in? Equals get tile at pellet eater.transform. Pellet eater.transform.position. Here's the position of this. Unless you're using the rect transform. If you were using the rect transform, you can get the 2D vector, but we'll just do this. So here's the position of the pellet eater. Find the tile that's in there. If the tile is equal to null, empty tile with no pellets. I mean, just return, really. But otherwise, num. Otherwise, if we get here, we're supposed to be eating a pellet. So let's give this a try and see how this works. You know, and if it works at all. First, I'm going to go ahead and delete. Make sure there's no pellet underneath or right next to this guy. So I'm going to hit play. Our character start moving. Does he have an oddball position? Is his direction not starting at 0? Oh, that's weird. Okay. Oh! See this? What's happening? My character is grabbing the wrong tile map, so he's treating the pellets as walls. Actually, hold on. Did I draw that on the wrong tile map? I have some things on the wrong tile map. Hang on. Oh, I forgot I duplicated the tile map, so it had everything. I duplicated it because I want to keep all the exact same setting, but I forgot it like copied the entire maze as well. Okay, I thought I drew on the wrong map at some point, but that wasn't it. Okay, clear all you out. Wall tile map, still there, still looking good. Pellet tile map. Boom, boom. Okay, let's try that again. So, there we go. This is what I was more expecting. See how I can walk through these walls? Because my character, when he's trying to grab the wall tile map, he's just grabbing the first tile map he sees, and he happens to be grabbing the wrong one. So I can walk through walls, but I can't walk through pellets because my character thinks the pellets are walls right now. So let's do a quick fix. So again, one of the things you can do, and this is the thing you'll usually see, in our maze mover, what you'll often see is people will do something like this. They'll set this to public, right? And then on our player, we expose the tile map, we can link it in there. Boom. So now this is going to be set to the right one. The problem with this is if we're spawning this maze mover from a prefab, we're going to have to assign this at spawn because it won't be able to copy this link over, right? This is great for something that's already in your scene, but won't work if we're respawning something, which is why I'm always a fan of doing something like this. That way it correctly grabs it when it spawns in for whatever reason, whether it's in the scene at the beginning or if it gets instantiated partway through, it'll grab it'll grab a thing and we don't have to worry about that. The problem is now it's grabbing the wrong the thing. So we need to know how to grab the correct the thing. And what we could do is we could grab objects of type and then loop through all these and find the one with the right name. Sounds terrible. You know what doesn't sound terrible? Our wall tile map over here. Let's get a new component called wall tile map. That's going to do nothing. Maybe it'll do something later, but it's going to do nothing right now, except the fact that it's going to exist, which means now in our Mave Mover, what we can actually do is say, hey, find me something that's a wall tile map, and from that, get the component called tile map. Now all of a sudden it should work. Yeah, Game Manager Singleton could also absolutely work. Oh, the nomming works. Awesome. And then we should actually discuss that. The other thing you can do is you could have, please stop running, thank you, is you could have some sort of object that's like your game, kind of a game manager. This is great. Let's definitely talk about this because I do this a lot. So this thing called Game Manager might do a lot of things, keep track of our score, do all kinds of stuff, but what it could provide is a central public lookup public lookup for, I guess we want a lowercase m for consistency with how Unity is doing it. Something like this. So in your game manager here, yeah, you register your wall tile map. And then because it's public and it's basically a global, hell, you could even use a static instance and things like this, or sort of singleton behavior. It doesn't even have to be a mono behavior, I suppose. You could do all kinds of different things. Then your other objects can go and say, hey, game manager, give me the wall tile map, which may in fact be the smartest, because here's what happens. What happens when you change level? Which Kakaz says. Exactly. What happens when the level changes? Well, when the level changes, we get a whole new wall tile map, don't we? So that's got to be resynced. Now, for simplicity, and I mean, this is very global, but I mean, we're looking for a global way to get a handle on the correct tile map. Let's say there's a static public tile map. Well, you might want this to, in fact, be like protected with a public getter. This might be a little beyond scope of this particular thing. Something like this, anyway. So that the rest of your code can't just change the linked tile map willy-nilly. But if you've got a static public, then what we can do in the rest of our code, right, our wall tile map just becomes game manager dot wall tile map like this. And in fact, we probably don't even save a reference. Instead, what we do is whenever we have to use the wall tile map, like this, we just do this. And then, in fact, maybe instead of having the individual code call this, we could have the function in Game Manager. But I think it's actually better to do it this way. Like, how wall tile map is going to be stored in Game Manager, we might change it. Again, with different access levels, using setters and getters, accessors, various things like that. But the way it'll look, regardless of how it's implemented here, the way it'll look in the rest of the code, this is probably better. And then the question simply becomes, hey, how does this get set? Well, I mean, on the very first go, we could use exactly what we're going to do, whoops, over here. You know, just for now. Just for now, wall tile map will just get linked to game object dot find object of type wall tile map dot get component object type. There we go. Get component tile map. So this will have to be fixed later to support level loading. But by doing this, and, you know, to do, make the setting of this private, protected, something, you know, encapsulation. But now we don't have to do any work over here. We can get the correct, however that's going to be determined, we can get the correct wall tile map this way. And that becomes pretty cool. Anyway, that's back to working over there. We don't need the game manager. We don't need wall tile map does nothing. Like, that's fine. There's maybe other ways to flag it that way, but that should work pretty well. The pellet tile map is probably still going to just work this way. It's going to have its own local code, and it's going to be checking for that. And the nomming currently works, right? If we run that test, I think we were in a pretty good state. Well, the original, you're right, the original PuckMan only had one map, and that's fine. All it did is, like, reload its pellets, right? And then increase the speed of the ghosts and everything over and over and over again. There you go. So you enter the tile, it noms. Now, right now, it doesn't eat the tile. It doesn't eat the pellet. Move this over. If you watch chat, or the console log, so nothing, nothing, nothing. As soon as I enter into this, nom, 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 nom begins. So what we need is what happens when we nom a tile. Well, really, when a tile gets nommed, here, let's do a void eat pellet. And let's say we feed it a tile. So we're eating the pellet at this tile. And all this is going to be is my tilemap.set tile and needs a position, which presumably is in here. Actually, I don't even know if it is. We could do get tile data and all kinds of stuff. I mean, it's this here. I guess, okay. That's right. Set tile at. We'll also get a piece of code in here. Vector3 int. Tile cell. Well, I mean, it's the same code. We'd just be wrapping, like, this one line in something, so I think that's fine. We're just feeding in a position, getting the position, and then we are setting the tile, this, to be equal to whatever we pass it, like that. And then don't return. And don't return. So eat pellet at. We just give it a position. And what we're actually doing is saying set tile, pause, and we're setting it to null. We're just nulling a tile. Like this. I think. If you're just removing the tile, wouldn't it be easier to delete the tile at pellet eater position? Yeah, that's what we're doing. We're deleting the tile by setting it to null. Assuming I'm doing this correctly. I might be wrong. Let's find out. So, but theoretically, when we enter into the tile now, it's going to set it to null. It's going to erase that tile. We'll get one num in the debug log, but it shouldn't repeat infinitely anymore because it should get eaten at that point. Let's find out if it vaguely worked. All right, that's us. Going in there, boom. Num, it ate it, that's great. Now, the one thing that's going on, though, has to do with how our position is anchored and where it considers this tile eating to happen. So you can see here, This, at the second I sort of cross over the line into the next tile, it eats it. Whereas if I go to the right and watch it over here, you'll see that I have to basically overlap the whole thing because I'm not technically in the next tile until the bottom left corner of my graphic is in there. And only then does it count as eating it. Now, no matter what you choose as your anchor point for your sprites, you're going to run into some case where something looks weird. No matter what. Whether you use a center point, the bottom left corner, the top right corner, it doesn't matter what you choose. Something you'll do will look not right, and at some point you're going to have to do some offset math. That's just the way it's going to be. It's just the way it's always going to be. There's going to be one of these situations will be not right with whatever you chose as your anchor point. And in this case, run into it because we're checking the second we enter the tile. Which is correct for everything else. Everything else is wonderful that way. But it's not quite right over there. Yes, well, we were originally talking about a hitbox, right? You could totally do it with physics and all kinds of other things. 100%. What we might do for this one, though, is we might just offset it. Right? If we take this position, and what if we just add or subtract? I think add in this case. 0.5, 0.5f. What if we use this? This should mean we should be half into the tile before it eats it. Oh, there it is. See, that worked properly there. And the other side, nothing. And there it gets eaten. I think we got it right the first time. Which usually when I do offsets like this, I tend to do like, I invert the plus and minus. But now all of a sudden it looks correct. We're halfway into the tile, and that's when it eats the pellet. That looks about right to me. Basically, what we've done is we have a half world unit wide hitbox on our pellets. Except we're not having to do, you're not using this to the physics system or anything like that. This lookup it should be very lightweight. We're not having to check every pellet. We're literally just saying, hey, the tile I'm about to enter, does it have a pellet graphic or not? And that's it. Now, what we don't have is the ability to get information out of this pellet. Again, if we subclass the tile base, and then we do a lookup on that and use a custom brush and all those things, we can totally do it. But this code here, this Pellet Tile Map, we could, let me empty it. Hold on. I'm on Pellet Tile Map. I'm going to just clear those two. Duplicate. Fruit Tile Map and Power Pellet Tile Map, like that. Exactly the same code. And we can use different graphics. And then what we can have in our Pellet Tile Map code, we could have something like, what happens when we eat a pellet on this map? Public int pellet points. 1 point to eat a pellet. Public int bool required for level completion equals false as a default. Public float power seconds equals 0. This is how many seconds of like super power time where you can go and eat the goalies when you eat this. So again, sometimes it makes sense to do subclassing when there's a lot of custom behavior, but here there's not going to be a ton of subvariants. And a lot of this is sort of going to be shared. We might change our mind. So right now, what we would do is, so for the regular pellets, pellets are worth a point. We need this for completing the level, but it doesn't give you invulnerability. For the fruit, we don't need you to complete the level. You can finish the level without eating the fruit. In fact, if you finish the level before you eat the fruit, you lose out on the fruit points. Oh, that's tragic. But the fruit's worth, I don't know, 50 points, but it doesn't give you invulnerability. Our power pellets, I guess you don't need to eat them to finish the level, although you probably want to. Let's say the power pellets are worth 25 points, and they give you, I don't know, 5 seconds of invulnerability. That seems pretty good to me. What if you combine the pellet maps, use get tile equal pellet assets for pellets, another thing. Well, we're not checking. There's no prefab to compare it against, because I guess we could check the tile thing. There's some logic we can put in there, but it'd be pretty rough. Did I miss the assumption that the player is a square and fills the tile? That is indeed the case. That we're basically just looking at the presence of in a tile or not, and we're adding like a half buffer thing. A graphics tile, yeah, you can't. I don't think that comparison would work. I'm not sure. I might be wrong, but I don't think that comparison would work. There are other ways to do it. I think the if you're gonna have a lot of variation in what your various like tiles and pellets and things will be, I think then the best solution is to subclass tile base. And then when we check, you know, if we have over here and hey, there's a pellet that's not null here, then what we do is in like the tile weird, you know, subclass dot do eat pellet. You know, and this is some sort of virtual and override and things like that with whatever our actual tile, you know, this is. And then we do some other code on that. If there needed to be a lot of custom code and a lot of different pellets that do very different things, that's probably the cleanest way. Is you subclass tile base, and then in here you do various things, but you need a brush that was aware of those things and different things like that. For our case, for our simple PuckMan game, I think this will do it. I mean, this is pretty much all the information we ever need to know about the pellets. I guess in the PuckMan game, the fruits are often animated, right? To bounce up and down, so that you might want to break out something different there, but it's going to be out of scope for this particular tutorial. So now, whatever we do with the pellet, you know, when we eat the pellet, do the thing, points and whatnot. So we'd call our game manager and say, hey, you're in an extra point, or you tell the player, like the player mover or whatever, that, hey, you've got invulnerability seconds, which will tie into our ghosts in a second. So we'll do something like that. But for now, it's good to know that, hey, our pellet eating does work. So on our various little submaps over here, let's get a sprite for a power pellet. Maybe the big red one? Or potion? Kind of like the potion. Yellow potion? Pineapple for power pellet? I mean, that would be the fruit, right? I mean, we can use the red dot or the sort of fiery dot. What do you prefer for the power pellet? The thing that you run over and you're invulnerable for a bit. We could use the big, like, this is sort of a part of a spinning coin graphic, but big yellow dot. Actually, that might be the clearest. Is this a spark? Fiery dot looks best. Pink potion. Hey, thanks for the bits, Cleon. I think I'm going to use this one. But obviously, you know, power pellet. Boop. Apply. And again, I will say, one of the ways you can decide to change some of your alignment on your tile maps and things like that is you can mess with the pivot point, the anchor point, on each one of these individual sprites, but that's my least favorite because it's the one that's more fiddly because you have to do it for each individual one. It's easy to forget one and things like that. All right, so we have a power pellet. We're going to drop it in here. That's going to go into graphics, tiles, boom, like that. Excellent. And so we've got a slight difference. And then I guess we'll get a fruit in here as well. Oop, hang on, what did I do? I think I toggled that. Yeah, there we go. I like the pineapple for the fruit. Let's call it fruit 01 or 00, zero index fruit. Always zero index your fruit, you guys. Very important. And we're just using the one palette for everything because why not? All right, there we go. So now, on the power pellet map, now the one thing with this approach is because we have separate maps, we could end up drawing a pellet on the same like the same spot. There could be a regular pellet and a power pellet in the same place. So you're going to want to avoid doing that if possible. So tell you what, I'll do the pellets first, which is going to be admittedly a little time consuming. Maybe I won't fill the map with it. We're going to find out some gap over there to do stuff. Throw some in there and over there. And I was going to say, oh, doesn't draw top to bottom. I mean, we do some stacking things. I was going to say, I think I accidentally drew some of this on the underneath the walls. Yeah, we'll probably want to set some sort of render order explicitly in here to make sure nothing like that happens. All right, we got some of that, and then, yeah, what we'll do on the pellet map, we'll delete there. Draw you there. Then on the power pellet, we'll grab this, drop you there, and there. And then, I mean, the fruit obviously shouldn't be there all the time, but we'll put one in there anyway. And all of these should work. You know what we don't have? We don't have the camera following our dude yet. But that's such a minor thing. Here, I can just play on the big map over here, and that's okay. Nom 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 nom. Nom nom nom. I feel like maybe we should move a little faster than this. Feels a little slow, doesn't it? Shouldn't pucks be black and the ice white? Well, that's actually a great point. We probably, I think if we did commit to the whole PuckMan hockey theme, I think we would absolutely do something kind of like that. If someone wants to draw a new tile set, like, go for it. Could be awesome. Okay. So that is working. I mean, right now, you don't get the points, nothing happens, but that aspect is working. Let's move on to the, yeah, speed isn't stressful enough. I agree. And yeah, with levels, the speed does go up. I mean, this might be the appropriate speed for level 1, because level 1 in Pac-Man is not very speedy, but we'll see. Make him go faster with more fruit he eats. You could do anything like that. So, I mean, the player itself, it just has so the maze mover has this speed here. So we would just change the speed in some way. Goes up with every level, goes up as you eat things, goes up with, I don't know, the player's heart rate, because you've got some weird, like, real-world biometric integration with your game. I don't know. You know, whatever. Let's make an enemy. Let's make a bad guy. I'm just going to copy the player. Although, well, yeah, he doesn't have the player mover script. He doesn't have the pellet eater script. So this is going to be, this is a goalie, right? This is an enemy. Oh, actually, I should just call it enemy. Player, enemy. Makes more sense in that particular context. You're going to start in the net, which, I guess -1 will center you up. That's going to be okay. We'll have to give you a different graphic as well, right? So we need a bad guy graphic. I don't know. I think this looks like a goaltender in full padding and equipment. It's been a while since I've watched some hockey, but yeah, that's how I remember goaltenders looking like, right? I think we can all agree. Green, and what we probably want to do is something like south, right? Because this is the facing south graphic. We're doing the same thing with the players. We may have some alternate. First of all, we might do the animations with them, and we might have alternate looks for when they're facing in different directions. So something maybe like that, but for now, we're just going to work with the one, and we're not going to care about rotation. So our enemy here, for their graphics, we're just going to point you to the goalie green. There we go. So we've got a bad guy! Hooray! And they've got the movement code in there. Now, is it going to do the weird thing where it moves to the left? It is. So, hold on. In our maze mover, our target position... Oh! I didn't realize it's because we set things with an initial desired direction. That way, when I was testing, I didn't have to hit an arrow key. But that's why they start by moving. If I just hit play, there you go, you correctly don't move. Excellent. So my player still moves around. Waka, 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 waka. But my enemies don't. So, let me close you. Actually, in theory, you can close everything. I'm going to leave Maze Mover open, but we're going to make a new script. So we have Player Mover. I'm going to make one called Enemy Mover. And again, we had a discussion last time. We could do subclassing, right? Enemy mover and player mover could be subclasses of maze mover. There's pros and cons to both. But in game development, really err on the side of adding components rather than subclassing, because except in certain narrow cases, it's going to be at least as good. Like it's going to be at least equivalent. And a lot of times it'll actually avoid a lot of weird, confusing stuff and weird stuff. So default to thinking of things as a component first, and only if it needs something else. So really, just like with the player mover, right? Like if we look at player mover, all it does is, well, we're going to have the same code over here, right? We're going to get a copy of our own maze mover. So the enemy is going to have its maze mover. And all it's there to do is, on occasion, change direction. That's it. That's our AI, is sometimes we put in a new direction we want to move in. And that's it. We just tell the maze mover how we want to move. So when do we do that? Probably on entering a new tile. Sometimes maybe when you hit a wall, right? So one of the interesting things about PuckMan is that the different ghosts actually have slightly different behaviors. It's subtle, but it's there. At its core, we want to have the opportunity to reevaluate our movement every time we enter a new tile, right? When we reach a tile, we should have an opportunity to say, hey, maybe I want to change directions. Sometimes I'll do it when I'm at an intersection. Sometimes I'll only do it when I hit a wall. I don't know. Program a full maze solver AI. Well, that's the thing. We don't want this AI to be that smart. It wouldn't be that difficult, really, to make a graph and do some A-star pathfinding over our maze. I mean, that's something, we've got tutorials for it all over the channel. We could 100% do an enemy that correctly tries to find the fastest route to reach the player. And we could even potentially predict them, right? Oh, the player's moving this direction, so instead of moving directly to the player, let's try to move like to a location a couple of tiles ahead of the player or something like that, so we can try to predict, get in front of them or do something like that. We could totally do that. That's not how the ghosts in Pac-Man move. I know you were joking, but it's actually a really good point of discussion. It's an excellent point of discussion. One of the funny things about game design is so AI is hard. Human-like AI is hard. Believable AI is hard. Oftentimes, perfect AI is trivially easy but wrong, right? It's incredibly easy to make, say, a perfect AI in a first-person shooter. An enemy that never misses is trivially easy because the AI can calculate exactly the correct vector to aim at for the player, could just aim in that exact perfect direction and get a headshot on every single shot. That would be terrible. Everyone would hate it. It would be stupid and sucky. So then the tricky part becomes, how do you make believably flawed AI? Now, some things like an AI for something like a strategy game, like Civ or EU4 or something like that, obviously that's an incredibly difficult thing to do. But even in those situations, you often don't want an AI that plays perfectly or even plays like a player. Often you want an AI that performs a role, right? What makes something like Europa Universalis or Crusader Kings fun or whatever is that the AIs behave sort of believably in terms of the character they're playing. In fact, even in EU4, the various kings have personalities, and that affects how likely they are to go to war, or this or that, or betray you, or do different things. And in CK2, is someone going to assassinate you or not? And they're not playing perfectly. They're playing based on their traits and their roles, and so you can sort of guess how they're going to play based on that kind of aspect. Anyway, in here, I think what we want is we want a signal to say, hey, you've entered a tile, and for our first go, let's just have it whenever a ghost enters a tile, it will try to see if it can change directions. Probably not going backwards, unless it ends up in a dead end for some reason, right? So let's say when we enter a tile, if we're moving to the right, we will attempt to move north or south. If we're moving up, we'll attempt to move left or right. If we're moving right, we won't attempt to move backwards, but we'll try to do that. If you do end up in a dead end, so let's say you're moving right, it fails, you're going to try up or down, down fails, then at some point it'll try left at some point and move its way out here. It might take a couple of frames to figure its way out, but it'll try. Let's do that as our first rudimentary AI. But that implies we need some sort of thing to let us know when we have completed a move into a tile. And for that, I think the best way is sort of an event. Right? Because our mover knows when we get there. Because we know if we reached our target. So if we get here, we've reached our target. All right, here we're still moving. But here, if we get here, we've just entered a tile. And we could just do a signal. Now, here's one example where having done a subclass would actually be fairly convenient, because really what we do is all the rest of the code that's here could be something like void on enter new tile. There you go. So what's nice about this is it's, keeping each one of these functions kind of slim. Update target position. We check a couple of things. If we get here, then we enter new tile. And that's when we're actually doing the update. But what's great is if we were doing virtual functions, we could, right? I can make this a virtual. If we subclass from this, then we can override this. Yeah, right. Default should be protected, for example. Right? And so if enemy mover was a subclass of maze mover, we could just override this behavior, call the base version. Well, actually, we probably wouldn't call the base version. What we do is we take a moment to update desired direction in our AI that we've overwritten it and done there. Totally fine. Ooh. I don't know why that got banned. Or do you? Wow, really? Seriously? All right there, Twitch chat. You're a little aggressive. Artificial stupidity. That's actually a good way to word it. That's the tricky thing, is implementing artificial stupidity that works well. Sometimes it's not artificial intelligence. So we've got this. So that's a possibility. The other thing we might want to do is use an event and some sort of signaling where people can register to be told when we enter a new tile without subclassing, which may actually be the nicest way of doing it. So for example, what we could do. So let's remove the virtual, the this, the that. Okay, I need to rename this temporarily. Let me just put an underscore over here for a second. Because what we want is we want a, I think, public event. It's been a while since I've used the word event, the keyword event, but event is kind of funny in that even if it's public, it's becomes semi-public. Other things can add themselves to it. We're going to have some sort of event called enter tile. So we need a delegate. Hold on. We need a public delegate. Void on enter tile delegate with nothing in it. And then we have an event with this function that looks like this. And then what we're doing is we're calling this. There we go. Really want to check to make sure it's not null, although it won't be. If this is not equal to null. So what do we, I'm going to explain what we're doing in a second here. On enter new tile becomes a sort of event that people can register to listen to when this event gets fired. And we're going to do that for ourselves. We've got this private code called on enter new tile. We're going to register as this as a listener to this event. So in our startup, again, there's a good chance I've made a syntax error here because it's been a while since I've done this. I'm doing it off the top of my head. On enter a tile, we're going to register a new listener for it. Like this. Now, I might not want to do it here because, yeah, you know what? I'm going to not have this set up as a listener for reasons that'll make sense in a second. Give other scripts a chance to respond to this event and maybe update desired direction. I think the order that these would be called in are based on the order that things get registered in, but I'm not sure if it's defined, and it may be wrong. It might be first in, first out, or it might be the latest edition gets called first. I'm not sure what order these events in. And we really want this to be last. We want to give other scripts a chance to possibly update desired direction before we go and trigger the rest. So we're no longer registering anything to this event ourselves. There is a listener that we're going to fire. Whenever we enter a new tile, we're going to fire that and give things a chance to respond to it. So now my enemy mover can do a thing where it's got, what do I call it? On enter tile or whatever? I mean, it doesn't really matter what I'm calling these things. Also, I need to move this just somewhere, just to like to define things up here. Oh, delegate. So I should explain some of the syntax here. Delegate, this is just defining sort of a signature for a function. I'm saying there's going to be some function, which I didn't spell right because I never spell it right. There you go. There's going to be some sort of function, and it can be called anything. Foo, blah. There you go. This part literally doesn't make a difference. This is what I'm calling a signature. This is a signature for a function that takes no attributes or takes no arguments and returns nothing. That's all. Like literally, no args, no return. This is what we're defining here, is a function signature. It's still not right? Okay, well that's fine. We'll fix it in a second. Oh yeah, I think it was the gate. Anyway, no args, no return is basically all we're defining here as a signature. And we're saying that there's an event called onEnterTile, and all the functions for this take no arguments and return nothing. That's all it is. By convention, you normally tend to do, oops, delegate, like that, by convention, but it makes no difference. Okay, and so now, as long as we've got something that fits that, so, and again, we're calling this, and the name doesn't matter, but we may as well call it the same thing. We have our own function like that. So in our maze mover, dot on enter new tile, we want to register our own function, which is over here. So this will get called whenever we enter a new tile. And then we want to choose a new direction when that happens. Let's let it be completely random at first. So new.x, we want it to either be a +1 or a -1. Or a 0. I mean, I guess, yeah, we're only picking one of the two. So do we want, like, if random.range of 0 to 2, this will only return a number that's either 0 or 1. If you're doing this with integers, it is, the first one is inclusive, so it can return a 0, but the second one is exclusive. It's really convenient when doing, they set it up this way because it's convenient if you're doing it for arrays and stuff, because array.length. But it'll either be a 0 or 1. So if this is a 0, then we're going to randomize the x part of it. So let's have it be a new vector2, or vector2.0. So if we get here, we'll randomize the x. So new dir.x is equal to, and we'll do the same thing where we're basically flipping a coin. There might be a helper for this. If it's this, then we return -1. Otherwise, we return +1. And then we do an else, like that. And we're just randomizing the y component. Very dumb way to do it, but yeah. And we don't actually have to do the normalized. I mean, it's redundant because we're actually going to make sure to do it correctly. So whenever the enemy enters a new tile, this will get called. And we're going to set a new desired direction at that point. Now, is this going to get called the first time? I think it does. It's literally, as long as we're on our target, this is going to get called. And this will happen when the program runs, because we set our target to our current position. So this should fire basically right away and set a random direction. And desired direction here will do all the sanity checking to make sure that we are moving into a legal tile. So we don't actually have to worry about that over here. So in theory, except for the fact that I probably made 13 errors, in theory, when I hit play, our ghost should try to move around. Now, it might not be able to bust out of this. Actually, it should, though. Shouldn't it roll a 50? With every tile, shouldn't it be constantly picking a new direction? Okay, yeah, it is. And sometimes turning around. Okay, the area we were in was too small to be able to see it. Now, he's even going to try to change directions. Like, you know, when he's walking down a hallway here, he's occasionally going to randomly try to move to the right. But then the system's been like, no, you can't. So it's going to keep moving that direction, which is fine. It looks a little weird here. And we probably don't want the turnaround behavior, because that's not really how the ghosts in Pac-Man work. But otherwise, I don't know, too shabby. What we might want to do with the ghosts is actually start them moving, like, have them intentionally path out of the goal box here, because otherwise, yeah, this one's going to be stuck. Except when it happens to enter this middle tile, it has to randomly roll up. Which should happen at some point. Because shouldn't it have a quarter chance of exiting this every time it comes into this middle tile? But it's clearly not. So there's something that might be off. And now you're stuck in the corner. Yeah, something in our code is definitely off. We just get whiskey and chocolate. Hey, Sloppy Poet, thank you very much. Hey, Quill started Unity coding tutorials after getting inspired by the first PuckMan stream. Thanks for all you do. Well, thank you very much, Sloppy Poet, and I hope that you have fun doing a whole bunch of this going forward. Yeah, just log the direction. Probably. And also interesting, like, we may have to step through for, like, when it gets called. Because it might not be getting called in the right place. Right, and doesn't try it again when it hits the wall. If it enters a tile and then just tries to move so it's stuck, it'll just stop there, and it doesn't get called every frame. It only gets called on the frame it enters the tile, not every single frame. Well, it's down. Oh, no, because it should still be calling itself. And we got more whiskey and chocolate. Because if it's stuck in a corner, it should keep calling this over and over, shouldn't it? If y, then x equals 0. If x and... No, because it's being set to a 0 over here. Like, this would be redundant, because it's already a 0. Unless you're trying to say something else, Blanken. But I think this is the sort of thing you're saying, and I don't think that's the difference. Yeah, I'm not sure. Then let it run until it gets stuck too. What I should just do is just dock the tile palette there. There you go. That way I don't have to worry about opening and closing it again. Oh, Okay, well, that time it busted out. All right. So we still want to stop it from turning around, which might be part of the confusion, because then it would add a 1/3 chance of getting out. There could also be special logic if we're in the goal crease, then it always moves towards getting out. Like we could have a program pre-programmed in sequence to leave the goaltender area, which probably wouldn't be a terrible idea. So, do we have any way of getting what our current direction is? I mean, we have a set current direction, but I don't think we have a get for it. Oh, okay, never mind. We do have a get for it, because what we want to do is we do want to do a little check. If new dir.x is equal to get what's it, maze mover dot get desired direction dot x. No, well, that's fine. Right, it's if it's in the inverts, right? Which we can just do the dot product for, because that's the only situation it should happen where it should return a negative, right? Same thing as before. Or what if... You know what might be slightly better is... Okay, well, this is a very specific thing. Because what I was going to say is we can get the current direction, and if we're moving along the x-axis, then what we want to do is we just want to try turning left or right. But we probably also want the straight. Now, some of them should probably go straight until they hit a dead end. Some might want to turn the corner all the time. Okay, how do I want to make this default one? Because what it could do is effectively a switch of when you enter a tile, there's 1 in 3 chance. 1 in 3 chance that we keep going forward, 1 in 3 chance we try to turn left, 1 in 3 chance we try to turn right. Yeah, there are no dead ends other than inside the goal. That's true. And it will wiggle itself out. But would that be the best looking behavior? I think that might be it. I mean, it's just really the exact same. On entering a tile, as long as we don't invert our direction, we're going to be the same. It just comes down to how smart we want to write this. Maze mover. So if we do the absolute value of our old direction, not x, if it's greater than 0, moving left, right currently. We might want to weight it. We might want to give you a 50% chance of continuing forward, and then a 50% chance of attempting to turn left or right. That might feel pretty good, actually. And we can change the weighting on this for each enemy, right? And there could be all kinds of behavior. Like, some enemies might intentionally turn in a way to get closer to the player, rather than just moving randomly. So in the PuckMan games, each one of the enemies does have a slightly different AI. And choices they make when they reach an intersection. Some try to get closer, some are totally random, and there's a few different things. I kind of like this idea. So we do something like float, I don't know, forward weight. Chance of continuing forward instead of turning at an intersection. So that 50-50 chance of staying forward. We're moving left, right. if random.range from 0 to 1 float, if it's less than the forward weight, keep moving forward. Actually, really, that could really be over here. Way back over here. On enter new tile, keep moving forward. We just return instantly. Make no change. Keep moving the direction you're moving in. We might want something smarter to detect if we're plowing into a wall. We might want to force a turn, but that's a separate check, right? If forward would be moving into a wall, then we'd force a left-right turn. So, how? Do turn. Do a turn to the left or right. To do, if we would be hitting a wall, call do turn. But otherwise, all this then calls do turn. There you go. So all the same logic we had before. So here we're moving left, right. So what we want to do is turn to go up, down. So we want new direction dot y to be equal to this. Else currently moving up, down. Boom. We don't have to check about reversing direction at all. I got this. So, and what we can do is we can make this public, which is interesting. Because now we can have some ghosts are much more likely to keep moving forward, and some are much more likely to always change a corner. And they could feel slightly differently. So let's leave this one at half weight. Oh yeah, and it's not turning around at all right now when we're hitting a wall. That's true. We probably... So I need to explicitly make a change here if we're going to hit a wall. Because at the very least... Well, actually, I guess when we hit a wall, we might want to do a different turn behavior, right? Because right now, we just turn left or right over here. But what we might want to do is pick a fully random direction, except for the one we're going in. Pick one of 3 random directions. Because I kind of like this. This is, you know, do turn left, right. First question I have, at any point do we change the right direction in this code if we hit a wall? Do we set it to 0? No, okay. Because that's important. Now, I think we want a function that specifically says, you know, like, would be a wall. Or heading into a wall. Because right now we do this. I mean, we've got is tile empty, which is the way it works, but it's more like, I think we want a specific, like, public helper function that we can call from other things to say, if I were to move in this direction, would I be hitting a wall or something of that nature? I think the best sort of wording and flow that we want for that, so that we can make a call here. And we'll obviously use it here, because this is what it's testing here. Target position, normalize. I mean, it's the invert of is tile empty for a target position, which I guess would be fine if we just make this public. But you know what? I think what I like, public bool is hitting wall. I like this. Returns true if our, next, or our target pause is a wall. Which is just this code here. So it's the inverse of this. Again, we could put a little exclamation mark. I like to be clear. So now we can just, first of all, change this code. Oh, you're good here too. No, that's fine. Good to go. So, is hitting wall equals false. Do this. We had this written this way originally. And again, the compiler's really good at unrolling these, false, 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 false to a clean, simple check. It'll inline all this and do the right thing. So if we're not about to hit a wall, we're good to go. And this being public, so what we can do here, if maze mover is hitting wall, then we can force a do turn again. Now, it might turn and still hit a wall, because if it's in the situation of a dead end, right? We're hitting forward, it's going to try up or down, which will hit another wall, and then next frame, it'll try left or right. It might pick right and hit a wall again, but eventually it'll get out after, a couple of frames, really. It becomes statistically impossible, or very unlikely that it's going to be stuck in the corner very long. And if it, spends a couple of frames stuck there, that's okay. And we can look at a cleaner, more elegant solution afterwards. Oh, maybe there must be something we're not updating, because I would think that would be up there. Are we not updating the direction? All right, let's change this to debug so we can actually look at some of the internal numbers. So it is, desired direction is still facing to the right. It's got the X of 1. That is not updating. I'm thinking on enter new tile isn't triggering over and over and over again. I thought it should trigger on enter new tile if it's not moving. Oh, it is. It definitely is. I might have to go into actual debug mode here. This is definitely running all the time. Oh, it ignores, because here's what's happening. Oh, it's not hitting this. I know why. Because while we don't change the direction, when we hit a wall, we don't reset the direction, but we do set the target position. If we're hitting a wall, we reset the target position to be the tile that we're in. So we almost have to ask a question of, so it's less is hitting wall, it's more like is going to hit wall, which is target position plus direction. Yeah. Now, there might still be something else to fix. Okay, there we go. Yeah, and I know what it is. So now we are calling, we're going wall, bop, 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 and it's running over and over and over again. So what's happening is it's saying wall and it's running do turn. Now in do turn, we do some code to turn left or right, and then we set a desired direction. But it ignores, it does not let you change the desired direction if it would slam us into a wall. The thing is, we might not need this. We might allow the desired direction to change even if it would slam us into the wall, because I think the rest of our code won't let us do that. Because we've got the sanity checks in the updating of the target position. The actual direction value here doesn't get used so much. It gets used to determine the target tile, which we should have some sanity checks on. So, there we go. Let me make sure that I can't move into a wall, and I can't. Oh, hold on. Now that's a thing. For our player now, if we hit down, it stops us, because it's setting the desired direction to move us downwards, but it knows that's not legal. So we get this sort of behavior that doesn't look right because it stops us from moving. So we're going to have to make some sort of direction, some sort of choice here as to, does it update the new direction, which is nice for the AI so it can know if it's going to hit a wall or not. Maybe we'll set a Boolean to say something like prevent invalid direction, which will set to false. So if prevent invalid direction and the test position is no good. Well, hold on. Actually, let's do it this way. If we prevent invalid directions, then we run a test. And if so, we bail. And it's defaulting to false, so in our player mover, that's the only place, really, where we don't want this update. So we'll put in a true to prevent an invalid direction from being selected, which stops the player from stopping dead end's track when you hit up and down. I'm like, why is the AI turning around? But now I know. It's because every time it enters a tile, it tries to turn a corner, and sometimes that will lead to an illegal direction. So it'll move up. So then it knows that's hitting a wall. So like this moving back and forth, right? It's moving here, it's changing, it's trying to randomly choose up and down. It chooses up, and bonks the wall, and then chooses the left or right direction. So it's flipping back and forth in a way that's unappealing. So I think our little simple fixes here. What I was trying to avoid is having to do a check-in here. But I might have to. Maybe is going to hit wall. We feed it a direction. Maybe would hit wall. Vector 2, test direction. That's probably better. We do this. We get rid of this. We assume we never want to feed in an illegal direction. Okay. Let me check. Our player should be... Oops. I'm trying to remember where I was. I think right now the player's fine. Yeah. Doesn't stall out weirdly. Okay. This is correctly knowing it's got to do a turn. And it's back to the set desired direction. Doesn't update direction. Here's what I propose is the smartest solution. If we're about to hit the wall, invert the direction, and then try to do a turn. I think that's the slickest. Yeah, hold on a sec. I like this. I like this a lot. There's a few different solutions, but I really like this one, I think. If we're about, if we're face planting into a wall, first invert our direction. Then we decide if we want to keep going straight, so backwards, or attempt a turn. I like this a lot more. So if we're about to hit a wall, then what we want to do is invert. I guess we can just multiply both, right? Vector 2 new dir is equal to maze mover dot get direction. Get desired direction. New dir dot x times equals -1. So, and the same thing with y. I mean, one of these is just going to be a 0, which doesn't matter. The other one's going to get flipped. And then maze mover dot set desired direction new dir. So first we try to go backwards. And then we might still change a corner. Case of face plant is a perfectly valid implementation. Yeah. This might... So there's lots of solutions, but this one might feel sort of the best in terms of what behavior we actually want. Now, there should still be, every time you enter here, well, there's a 50-50 chance you go straight, and then, so there's only a really 25% chance of turning a corner, although it's never happening. Oh, no, there it goes. Okay. I think we need to dramatically lower the chance of going straight by default. First of all, let's set it to 0, so they should always attempt to turn a corner. Hold on. That was weird. They went diagonal. Okay, now it's looking correct. Now, in this case, it didn't always look like it turned a corner, because sometimes it'll try to turn in a way that's a wall, and so it'll still accidentally end up going straight. So sometimes in a T-junction, sometimes even with a 0% chance, it'll still go straight because it's got a 50-50 chance of trying to turn into the wall, which won't be accepted because we don't allow you to choose a direction that's invalid. So if you try to turn into a wall, the system will just ignore it and you'll keep moving straight. And that's fine. I'm still a little confused why this guy didn't break out of this. Hit a wall, inverted direction, and then goes up. Hit a wall, inverted direction, and then tries to turn left or right. And sometimes it goes down, and that's nothing. And sometimes it goes up. So I think it was predicting that it wants to go this way. Like the current target would be this, and then it does that. Do we need to update? Do we want to force an update right then? So if the set desired direction is an inversion, which is what's happening here, it updates immediately. Yeah, we could query for valid directions, but there's a weird timing thing that happens here. Yeah, see, now you bust out without the diagonal. Which is lovely. What it means right now is the player can't instantly flip back and forth. There's that lag. But was there a bug before? Was my player allowed to do weird diagonal motions with this? Just like the AI? If I go left, right, up. I'm being chased. Almost looks like using it on purpose. How come the AI... We are calling update direction twice per frame. Is this? Yes. Sorry for the silence. So what's happening is it's inverting, it's updating, right? So there's probably a case where the player can do this too. Well, maybe it has to happen in the same frame. It actually might have to happen in the same frame, which is what's going on there. What I might want to do... Assuming the player can't screw it up, we could just put a Boolean that gets passed here that prevents the instant direction update for the bad guys. Because, yeah, it's... Because what's happening... Okay, the bad guy inverts his direction, so this gets set. This updates right away. So now the target position... So let's say he was going left. I don't know. I think I'm probably mirrored, but from my point of view, I'm going left. I'm hitting a wall. So it's flipping its direction. It's updating its target position right away. So now its target position is the tile over here. And then it's rolling up or down, which can update and bases it off the target position, so it goes there. So now it's just trying to move across that way. We do want a forward-looking thing here, though, don't we? Yeah, then it doesn't update the target position a second time. No, it doesn't. Yeah, sorry, it doesn't update the target position a second time. The target position updates immediately to be the one to the right. Even though it's got a direction of up. Is this dot product actually incorrect? Is it returning less than 0 on a perpendicular movement? No. Even with this. It's definitely this that's messing it up. I'm just trying to avoid another, you know, passing another Boolean. See, now it looks perfect. I mean, I could do a special thing for the player, so it can instantly update one back and forth. It seems really hacky, though. You know? Bool can instant update, which defaults to false. This is a duct tape solution. If can instant update and the rest. This is just, yeah, it's very, like, I'm just using chewing gum and duct tape to fix this. Although I guess we can still use the cleaner line here. But I think I'd have to sit silently and meditate on it and not stream to fix this. Now, only the player can insta-update. So you still get the snappy back and forth motion as a player, but you don't get weird diagonals over there. I don't like this fix. It fixed it! But not in what I consider to be the correct way. So, yeah, I would have to sit silently and then, like, it'll, you know, click in, but can't do it right now. But we can pick up stuff. The power pellets don't give us invulnerability or points or anything like that. But hey, we've got a dude who moves around. But, so, that's the basic AI. But then what we could do, if you wanted a smarter one, right, for the do turn, well, this would actually be probably a fine place to subclass. If this, you know, so we have something like virtual, and then we can override it in a slightly smarter enemy. Because instead of choosing left and right, instead what we do for a smarter AI, right, a smarter enemy might ask, is the player above or below us, and weight the Y direction accordingly, right? So if the player's at the bottom map, we're at the top, and we get to it, we have to make a choice between positive Y or negative Y. We're going to want to move negative Y to move down that way. Sometimes it might not lead us to the actual player, because we're not actually doing actual pathfinding, because that's not what the PuckMan games had. But some of the ghosts would try to turn in the direction of the player. If it's dumb and it works, it isn't dumb. I mean, that's and way to think about it. Put in 4 ghosts, obviously they're all going to look the same. But then they're going to spread out. There we go. Waka 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 waka. I mean, it's definitely a thing. But yeah, we'd want some of these to be, we want one of these to stay this like uber random, I make just completely bonkers decision at every intersection, which is completely unpredictable. But then we want some of these to change their straightness. First of all, that would change a lot. Oh, let me change out of the debug mode over here. We'll go back to normal. So this guy will put in a 0.25. This guy will put in a 0.50. He really likes to go straight. It might mean he'll take a long time to get out of here, but it also, that will separate these guys a little bit more. And then the last one might have like a special Boolean for seeks player actively, right? But that does nothing yet. Well, seeks actively. Again, it's a little misleading because it's not really seeking the player. I was going to say, this guy's going to have a really hard time because he keeps bouncing back. What we might want to do is put a special flag on a tile here. And that might be the check. Basically, some special logic for the for these guys. It's like a one-way gate. But basically, if they're next to the exit tile, like if they're in the net, they want to go through the exit tile. But otherwise, the exit tile does not count as a legal tile to turn in. Like we could do some sort of special logic in that way. In terms of the monsters and the players colliding, again, we could... Okay, so that's the second time that's happened where they stop. And I think it's because they tried to move into the wall and then tried to move into the wall. I think they're not being called... the unentered tiles aren't being called anymore. Okay, you're one of the stuck ones. Number 3. You're stuck. Let me delete the others. Clear the log. Unpause. Yeah, see? On enter tile's not triggering for this guy. And why? Why wouldn't it trigger? So update target position. We don't have a forced update, so it's false. Target distance target, if it's greater than 0. So does it have a target position? Its desired direction is an x of 1, so it wants to move to the right. Local position. Its current target position is its own tile. I reset this to be exactly -3. Oh. But he's at -3.00001. So it wasn't exactly on target. So the distance to target is greater than 0. So it's not doing an update. And yet, yeah, it's greater than 0, so it returns right away. But then in the move to target position, it's not actually moving because it's probably a number that's so small it's rounding down to a 0, so it's not actually moving. So this can happen sometimes with floating point numbers. The concept of zeroness is a little fuzzy. What we should probably do is put in some sort of number greater than 0. But that's like close enough here. If you're within 1/100th of the target, that's going to count as good enough. So we only count ourselves as not being there if we're more than 1/100th of the target away. So then we return that. Otherwise, we're going to assume we've reached the position. So if we're within 1/100th of a world unit, we assume we reach the position, which means you trigger all the on enter new tile kind of code. So that'll probably stop the targets from being stuck there. Now, the other thing we could do is in the movement over here, when we actually do the move to target position, after we do this, after we do the move, we can do a check here and say, hey, are we within, some tolerance number, 0.001 of our position? Oh, just set it to the actual position, which is actually probably better because these errors will keep adding up. I mean, we do have it set up pretty well to fix it. So let's set this to 0. Let's do a float tile distance tolerance. How close to the target position counts as arriving. So the tile distance over here, what we're going to do is after we move, if vector2.distance between our target position and our newly updated position, if it's less than, what do we call it? Tile distance tolerance. If it's less than that, oops. Close enough to count as arriving. So we're just going to set our position to be equal to the target position, like that. That's probably a little bit better, because then, yeah, when we're in a position where we count as being in that tile, it's actually, our position's actually going to correctly represent that tile. Now we should no longer have the issue with these guys just stalling out randomly. I mean, there's no way to know unless we let it run like infinitely long that it doesn't stall, but that situation that we were seeing, that's what was causing this. So I think this could, the creature movement could still be refined, and I think there's still maybe a slightly more elegant fix to both allow the player to like whip back and forth instantly and not have diagonals and stuff. But it's working, and yeah, if it's dumb and it works, then it's not dumb, is one way to look at it. I always liked, if it's dumb and it worked, you're just lucky. But I mean, this is not luck and randomness. It works because it works. It just doesn't feel elegant. It doesn't feel good. It doesn't mean it's a bad fix. One funny thing, you know, for the fruit tile map, I said in real life, I think the fruit bounces up and down. There's kind of sort of no reason we couldn't just, not the X, we couldn't just add a little bit of wiggle to the actual entire tile map up and down. As long as it's just a slight fractional change, like the math is going to work out exactly the same. Bounce FX. So all we're doing is we have some sort of float, which for a timer. T plus equals time.delta time, and we want a float for like time scale equals, I have no idea what this is going to be, times time scale. Another one, float dist scale, which is going to be quite small, something like this. So we set our this.transform.position is going to be a new vector 3 with the x doesn't change, the z doesn't change, but the y is going to be mathf dot sine of t times dist scale, because this will return a number from 1 to -1. So we scale it by this way. So the fruit should bounce up and down now. I was going to say, I think the time scale we're going to want to now bounces about 10 times per second. There we go. Rump. Okay, looks slick. Sine starts at 0. Yeah, but its range is from +1 to -1, right? Let's double the speed. Let's have the distance. Now, the entire tile map is moving up and down. And yet, I think that's fine. If for some reason they had more than one fruit, they'd all bounce together. That would be okay. And it's close enough that, like, it's always going to work with the collision. Technically, as you move up, like, it might slightly... Like, it won't actually hit it unless you've moved that extra 0.1, but that's okay. I think that's a slick little effect. I like that. Okay. We, in just a few minutes, we're going to be switching over to our multiplayer Stellaris, which is going to be for subscribers. Do make sure that you have gone and joined the Discord, and you'll get an invite through that. So be a subscriber. Instructions on joining the Discord are down below. We're going to do some multiplayer Stellaris in a second. Did we have anything outstanding and any questions? Oh, there's a camera thing. The naive way of doing the camera, the naive and not necessarily ideal way of doing the camera, is to just make the camera a child of the player. And then as the player moves, the camera will also move. Oftentimes, you don't want this exactly, because you do get, like, the whole move, which actually, it might be perfect for Pac-Man. Well, first of all, in real Pac-Man, the camera is just zoomed out enough that you see the entire maze at once. But we might want the ability to have bigger mazes, smaller mazes. Maybe we don't want, you know, we don't want to see everything simultaneously. It does mean we don't have full information, which is a little dicey. At the very least, we certainly want to zoom the camera out some more here, I think, so that we can see more of it. And we can even calculate a size here that will encompass the whole thing. Because what is the size? The size here is how many world units tall the orthographic viewing space is. And it's treated like a radius. So there's 10 world units of space from here to here, and another 10 to the bottom. So we could take a look at our wall tile map, figure out how tall the tile map is, and then feed that into the orthographic size of the camera, and we'd see the entire map the whole time. No reason we can't do that. On the other hand, maybe we want to have a fixed zoom level where, you know, it's like, oh, you know, it doesn't look really good here. We like, I like this. I like 6. You know what? That appeals to me because of whatever arbitrary reason, I've decided today that I think it looks great at 6 here for the amount you see at a time. You can see enough around you that you can dodge stuff, but you can't actually see the whole screen, and that might be kind of interesting. Again, we know these green lines, and we talked about at the start of the stream about how to fix it. We fixed it for the main tile map, and we could fix it for the rest, but we're just leaving them be for now. And depending on what zoom level, the green lines are more or less visible. But again, we've got the fix for the tiles. We could fix everything. And like, okay, if I like that, that's quite good. Now, again, I would sort of recommend resisting the urge to make the main camera attached to the player. First of all, what happens when the player dies? If you destroy the player object, you're destroying the camera at the same time. All right, that sounds pretty less than ideal. But the other thing is you may not want a fixed one-to-one motion with the camera. If you think about something like Mario Brothers, everyone's played Mario Brothers, the camera isn't attached to the player. What happens is as the player's got a little bit of wiggle room, a little bit of a threshold, and as you move out of this, as the player basically gets too close to the edge of the screen, then the camera follows. That's one way of doing it. The other way that I kind of like is maybe sort of a slow leash where it's following. That can look kind of nice. So what you would want to do for your camera is you want to separate it from the player, and you're going to want to have some sort of like camera follow script. There's a billion examples of these. There's even some pre-made stuff. But ultimately what you do is you have some sort of game object, or, I mean, in a sense, it's just the transform. Target, transform. This is the thing we're here to follow. And you make this public, but you can have, you know, and maybe with this, you do something like, hey, if target transform is equal to null, player died, see if we can recapture it. So you can make it public and link it through the inspector, or you can just do this. Because then what we're doing is we're trying to do game object dot find object of type. Now, we may have registered the human player some other way. Our game manager, right, this might be a good example for the game manager as well, knows what the current local player is. But we're going to do this lazy here, like player mover dot transform. To do, if this becomes, well, player mover is always going to be the local player. So network players are not going to have a player mover script. But what if we have local multiplayer, right? And then you're listening to different inputs, one from the joystick, one from the keyboard, one from the right side of the keyboard, one from the left. Multiplayer, I'm spelling that way, then this will break. And we'll need a smarter solution for what is it. In which case, if you have multiple players on the same thing, you might want a smarter camera that keeps both players within focus at the same time. If they get close, maybe you can zoom in. If they spread out, you can zoom out. Maybe that's what you want. Or maybe we redesigned the camera system to see the entire arena all the time. I mean, whatever. But this will do this. So we're going to grab it. Now, this would actually be a pretty good use case for the question mark dot. Because it's possible that there's no player. If he's dead, if it takes 2 seconds for the player to respawn, in that time the player may simply not exist. In which case this would return null. If we do a null.transform, we get an error. By doing this, it'll only return the transform if this part isn't null. So I think, and I don't tend to use this operator very often, because A, it's a little newer to me, and B, it's not always obvious and clear what's going on here. You could do it explicit. You know, grab the player mover. If it's not null, set the transform, blah, 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 blah. But I also want to do another thing. If this is still null, and someone with a little bit more modern C#, you can double check that I'm using this right, but we'll find out in a second. Still null, so the player must be dead. So we'll just return, because we don't need to move the camera right now, because there's nothing to follow. Or we'll do a different animation, or whatever, I don't know. But then here, what we do is follow the player. So we've got a target transform, and we want to move to it. Now we can move instantly, but it might be nice to move sort of slowly to the target. You can do it with a lerp. I would recommend absolutely to try to use a smooth damp. So vector 3 or 2, whichever one, has a smooth damp. Actually, Math F has a smooth damp as well. Including one for angles. These things are really nice for making great smooth movement. So you can see what the variables are here. We need our current position, so transform that position. We need to know our target. Okay, that's our target transform dot position. It needs a current velocity, and it's a reference, so this will get changed. You just need to have a vector3 current velocity. And this is a value entry as opposed to a reference variable, so it gets instantly instantiated to like a 0 vector, so we can just feed that in without doing any extra work. It needs a smooth time, so it's basically how long it should reach. I don't know, half a second? No idea if this is what we want. Smooth time. And if there should be a maximum speed for the camera, but you can see it's optional. You can feed in a delta time, but I think if you don't, it just reads the system delta time if you don't pass one in. I think. Oh yes, needs to be passed with a ref keyword. There we go. Now, this returns the new position, so we still have to go and set our position to be equal to this. So this should smoothly move the camera to follow the player. The further away the player is from the camera, the faster the camera should move. Oh, hang on a second. What's happened there is it's also moving our Z coordinates. So it's moving our camera to be in line with the player, and then we can't see anything anymore. Plus, that Z movement is eating some of our velocity, which we don't want. We want to 2Dify this. So what I think we'll do, vector3 clean pause is equal to target position, except we're going to set its Z to be equal to our current position, .z, because we don't want that to change, and we want to use the cleaned position for that, or the Zified position. That should no longer change the positions, the camera's Z. And there we go. So it's following along, and it's got a little bit of dampness. Now you can see here as I change position, you can see it like, oh, takes a second. The camera sort of lags behind for a second and then catches up. I think that's very appealing. Now, this is different from a threshold where the camera wouldn't move at all while we're doing back and forth until we got far enough away from the center of the camera. Then it would start falling. But we could do that too. We can do that with the smooth damp. Some sort of like float threshold equals, I don't know, 2, which is probably more than we want. If the player is within this distance, don't move the camera. Clean Z. So we do something like if vector3 dot distance of our current position and the clean position is less than the threshold, then we just return. Now, I think 2 is going to be like ridiculously large. Where is it? Actually, it might be okay. So now if I go back and forth, the camera's not moving at all. It doesn't move at all until I get a little too far away. And then again, it sort of stops for a bit. Yeah. Oh, but then it moves in other directions as well. Yeah, I don't think that's quite what we want. Although what we could do, if we just reset the current velocity, that, first of all, that's probably correct, but I still think that overall it's not going to give us the visual thing that we really want. I've seen first-person Pac-Mans. Now the camera's stuttering a little bit as it catches up. I mean, we could slow it down. We might want to give it just like a tiny microscopic, and that actually might be all we need. It's just a really small threshold, just in case we're wiggling back and forth, so the camera doesn't judder back and forth. I don't think it actually matters. It actually looks kind of nice when we're changing directions, because the camera actually does stop for a second before it starts up again. Not bad. Exactly. And no, I am not the seems good guy, which is super obvious on like the higher res version. But in the tiniest little example of the seems good guy, it kind of looks, especially when it, you know, without the long hair, without the COVID hair. Okay, let me scroll back. No. Watching Quill is always a smooth time. Nice. Any other questions or things? Which channel in Discord? It's actually not going to matter. I mean, join the Stellaris channel, like for us to chat about the game and not pollute general with it. But I'm going to be getting you guys to whisper me for the invites to the game in a second. Last attempt for notice. I know you're not ready for this yet, but I think an awesome pickup item would be a penalty whistle that sends all the ghosts back to the start for 10 seconds. Oh shit, that's cool, Mesker. That's really cool. I like that. That's really funny. Yeah, even the fruit's like, you know, are you grabbing a helmet? And what should the fruit look like? Should be other, you know, hockey sticks and other, you know, hockey type references, or maybe just stuff that you would have a hockey game, like, you know, a hot dog or something like that. I don't know. Your hair's only as long as mine before Corona. And my hair used to, like way back in my well, I was gonna say not teens, because in high school, if it touched your collar, the nuns would come by with scissors. Yeah, no, really. So in high school, my hair was limited in length, but then in university, it started to really grow it out. So it used to be longer than this, but this is pretty close to as long as I ever had it in life. Went to nun school? Yeah, man. My school was run by nuns. I mean, there was plenty of, you know, lay teachers as well, but yeah, no. Our principal was a nun. I had a nun who, as an English teacher, a French teacher, a history teacher, chemistry teacher. Mm-hmm. Yeah, yes, I went to a nun school to become a nun. Yes. No, a school run by nuns. Yeah. Mm-hmm. My favorite teacher of all time was a nun. My least favorite of all teacher of all time was a nun. So they really span the gamut. They really span the gamut. All right, anything else before we switch over to doing some Stellarising? Need a slap shot puck that zips a distance takedown keeper. That, you know, what'd be funny is if you run out of the power thing, it doesn't give you a power mode, but instead, yeah, it's a puck that goes like pew pew pew. It pathfinds itself to the closest ghost and just like knocks it out or something like that. That would be kind of awesome. Mm-hmm. Non-school? Ooh, yeah. School run by Indian flatbread. Mmm. So hungry all of a sudden. God, I love naan. Dun. All right, well, it doesn't look like there's anything too big coming in, so we're going to switch over. We're going to take a short break while we set it up, but we're going to make a switch over to the Unity. I think this is the end of this specific tutorial series. Now, there are some other things that would be interesting to look at that I might do as standalone episodes using this as a base. An item that turns the floor to ice. Oh, because everyone loves ice physics. That's everyone's favorite video game mechanic, right? All right, so here's how this is going to work. If you want to get into the Stellaris multiplayer game, make sure you're on Discord. Send me a whisper on Discord. And what I will do is I will send the game ID and password to the people who whispered me. And just in case we get too many people and the game becomes unstable, I might just limit how many invites I send. Although I don't think we're going to get an overwhelming number of people. I suspect, you know, because we can do a couple of dozen really easily. So we're going to do a little multiplayer Stellaris for about an hour on stream. And then after that, a Kiss for Lux stream starts, and I intend to keep playing some multiplayer Stellaris for the first hour of that, maybe, because I might also be considering joining maybe the Hearts of Iron multiplayer over there, so I will make some decisions. But we're going to take a short break. When we come back, Stellarising. So if you are a subscriber, make sure you're in your Discord, and if you want to join in the Stellaris, send me a whisper, and I will fire an invite over your way. So I will see you guys in just a couple of minutes.